This is everything you need to know for Precalculus, Part 8. So we're going to talk about how to identify a point of continuity. And so in our example, we're going to look at, is f of x equals to 2x squared minus 3x minus 1 continuous at x equals 2, okay? And there's 3 steps that we have to do to see if that is true. So the first step, or number 1, does f of 2 exist? So remember, anytime we have f of 2 or function notation like this, that just means if we plug in 2 for x, do we get a real number? Okay? So we can easily test that by plugging in 2 for x. So 2 parentheses 2 squared minus 3 times 2 minus 1. Okay? And we're going to simplify that. So 2 squared is 4 times 2 is 8 minus 3 times 2, which is 6, so minus 6, and then minus 1. So 8 minus 6 is 2, minus 1 is 1, so that is equal to 1. We get a real number, which means that f of 2 does exist. So we're going to put a check mark, okay? The first step is looking good. Now, the second step is, does the limit as x approaches 2 of f of x exist? Okay, is there a limit? So the way that we're going to check this, and I've already done it for you, but if you make an xy table, okay, we are going to check as x approaches positive 2 from both sides and plug in x values such as 1.9, 1.99, and 1.999. So we're getting closer and closer to 2. And then the same thing on the other side as we approach from the other side, 2.001, 2.01, and 2.1, okay? And as we plug in those x values into our function, or just get a table, we're going to get the corresponding y values and plug them in our table. Okay, so we already found what f of 2 is, which is 1, but now we plug in the rest of the y values, and as x approaches 2 from both sides, we want to see, does our y value get closer and closer to 1, okay? Because remember, we don't want to have any jump discontinuities, infinite discontinuities, or removable discontinuities. So as we approach x equals 2 from the right side, it appears that our y value is 1.52, then it's 1.05, then 1.005. So we're getting really close to 1, so that looks good. From the left side, we have 0.52, 0.95, 0.995. So again, we're getting really close to positive 1 from both sides, which tells me that this is looking good. It's probably going to end up being continuous, but for now, we're just going to put a check mark. Okay, the limit does exist, and we can even write the limit as x approaches 2 of f of x is equal to 1, okay, because we approach 1 from both sides. Now, the third step before we for sure say that this is a point of continuity. So does the limit as x approaches 2 of f of x equal f of 2? Well, we found f of 2 up here is 1, and then we also found that the limit as x approaches 2 is also positive 1. So those two things are equal, so we can put another check. And so we can confidently say that at x equals 2, f of x equals 2x squared minus 3x minus 1 is continuous, and that is how you check that algebraically. So I hope this video was helpful. If you want to see more like this, go ahead and follow this account, like this video, and leave a comment. That way my videos show up in your For You page later on. We'll see you next time.